So to finish up this lecture, we're just going to talk a little bit about acids and bases, and if you guys have ever had a fish tank, you've probably had to deal with having water that might be too acidic or too basic or something like that. But I think we've all heard of acids or bases, but let's kind of dig in a little bit further and see what they're all about. So basically, water can dissociate into two different types of ions. So water can kind of break apart or break down into what they call hydronium or hydroxide ions. And changes in the concentration of these two different types of ions can have a great impact on living organisms because they can affect how acidic or how basic water can become. Let's specifically talk about the difference between an acid and a base. So here it says an acid is any substance that increases the hydrogen ion concentration of a solution. All right, so what does that mean? Basically, it's saying that if you have a substance that causes there to be more hydrogen ions in our aqueous solution, it's probably going to be considered an acid. Okay, so acids have more hydrogen ions in them than a basic solution would have. So the definition it gives to a base is any substance that reduces the hydrogen ion concentration of a solution. So if you were to have a basic solution, you're going to have less hydrogen ions than you would have in an acidic solution. So if you talk about acids and bases, you have to refer to something called the pH scale. And basically, the pH scale is how we're able to measure how acidic or how basic a solution is. And it ranges on a scale that goes from 0 to 14. Okay, so again, if we're talking about pH or if we're talking about acids and bases, we're talking about how many hydrogen ions are in a solution. Okay, so the pH of a solution is going to be low in an acid. And this confuses people sometimes because in an acidic solution you have more hydrogen ions. But if you're talking about the pH scale, if I say the pH of a solution is 0, that's a really low pH. And so what that means is that's going to be a very strong acid. On the other hand, if we're talking about pH, bases are going to be high on the pH scale. And we'll look at a picture of this in just a minute and it will help clarify. So here's our pH scale. And as you can see, it ranges from, on the top, there's a red bar that says pH is equal to 0. Whereas down on the bottom, you have kind of a pinky orange colored bar that says pH is equal to 14. So you have to have a pH between 0 and 14. All right. And again, we said on the pH scale, acids are on the lower end. Okay. So you have, it says pH of 0. That's a really strong acid. We have battery acids, hydrofluoric acid. Okay, these are really, really dangerous acids that have a lot of hydrogen ions in them. On the other end, we said bases tend to have a high pH. Okay, so if you have a pH of 14, that means you have a very strong base. It's about as basic as you can get. And so an example here is liquid drain cleaner. Okay, pH of 13 says bleaches, oven cleaner, right? So don't let that confuse you. A low pH means you have a strong acid with a lot of hydrogen ions in it. A high pH means you have a strong base with very few hydrogen ions in them. So you might have asked yourself, or not, what is the optimum pH for a living organism? Well, we want our internal cells, or the pH within our cells, to maintain kind of a range around 7, or a value of around 7. So the internal pH of most living cells must remain close to pH 7, and they typically call that a neutral pH. Okay. Now, when you're referring to pHs, you also want to consider something that they call buffers. And buffers are basically substances that help to minimize fluctuations in your pH. Okay, so here it says buffers are substances that minimize changes in the concentrations of hydrogen and hydroxide ions in a solution. All right, and at the beginning we said that water molecules tend to dissociate into those two items. So if hydrogens are what are affecting, or hydrogen ions are what are affecting the pH of our solution, we want to minimize that change. So let's say we have a fish tank and our fish need a pH close to 7. Well, what we can do is if we're having problems keeping our pH, the pH in our water around 7, what we can do is we can put in a buffer. Usually it's like powder or something you can buy at the pet store. So you can put in buffers that are going to prevent that water from becoming either too acidic or too basic, and that's going to maintain the health of your fish. And basically what a buffer is it's just kind of an acid-base pair that work together, and they kind of reversibly combine with hydrogen ions so you don't get that big fluctuation in pH. Now, something that was in the news quite a bit, probably about 10 years ago, 10, 15 years ago, and it's still a problem, is the threat of something called acid precipitation. And this is kind of, really been noticed within the past 20 years. And basically, acid precipitation is something that refers to any form of precipitation, whether it be rain, snow, fog. But what they were finding is that whenever this precipitation would come down, they were finding that the pH in it was exceptionally low, lower than about a pH of 5.6. So this rain that was coming down was extremely acidic. And like we just said, most living organisms require a pH to be about 7. So it was, causing a lot of problems in ponds and in different forests up in the Northeast. It was a pretty big deal. And basically what happens is as we pollute the environment more and we put more pollutants into the air, it's causing that precipitation to become more acidic. And what happens is eventually it damages the life and damages different ecosystems throughout the world. So here we have another illustration of the pH scale, again going from 0 to 14. And you can see on the top of the picture, or on the bottom end of the pH scale, we have this kind of area that they consider acid rain. Okay, and so you can see, depending on what the pH is, how it starts to affect the environment in different living organisms. So at about a pH of 4, we can see that at this point, fish reproduction can be affected, right? So that's not a good thing for food sources, or if you're interested in fishing just as a recreational activity, that's going to start to impact those fish populations. If the pH gets even lower, we're actually going to start to have fish die off, right? So acid rain isn't a good thing, and fortunately, a lot of attention has been brought to it, and people are starting to become more aware of it and are starting to find solutions to the problem. This final slide just kind of illustrates just a lot of the effects that have happened because of acid rain. And in the top left picture, you can see, again, when we put pollutants into the air, when we put sulfates in the air, and so on and so forth, they get deposited into the atmosphere. And then when we get the buildup of clouds or the formation of different situations where we're going to get precipitation, all those pollutants start to come back down to the earth in the form of acidic precipitation. And the rest of the pictures just kind of show you some aftermath effects of different ecosystems that have been impacted by highly acidic rain or highly acidic snow. So there's entire forests that have been killed off because of it. And then on the bottom right hand corner you have a statue, and you can see how it's starting to erode that kind of rock or that geologic formation that's built that statue, and how it's starting to kind of erode it or kind of break it down a little bit.